This is video 1 of 3 videos I'm going to be posting going through some of the material that we missed from class today. And we are going to continue exploring forces in motion using the examples of standing, jumping, and walking. The goals are to get practice with the free body diagrams, introduce the frictional force, and practice applying Newton's laws. Our first example is a kind of warm-up example. It should be pretty straightforward. It's just me standing there, and this is my best picture, best self-portrait of me standing in on a PowerPoint slide. And what I want to consider is, what are the forces acting on my feet at the bottom of my legs holding me up, and how would I find those forces? You're going to have to be given, and I'm going to give this to you in a minute, my mass. My mass is 80 kilograms. And so take a second, pause the video, and draw the free body diagram of the forces acting on me, in particular on my feet, but on me overall, and then come back to it. So I'm giving you a minute to pause the video. So pause it now. Okay. This is my free body diagram. There should be weight, my weight, which is my mass times the acceleration due to gravity acting down, and the forces on my feet acting up. Notice that I've drawn, and I won't always do this, but notice that I've drawn the arrows so that the weight is much bigger than either of the forces acting on my feet. Right. And so now in my free body diagram, I've even more idealized myself to just a block where I've got two forces acting on my feet and the weight acting from my center of the mass. Okay, so we can now apply Newton's laws, and maybe I'll give you a minute again to pause that, I'll give you some quiet time to pause the video, then come back and we'll pick up. And I didn't tell you what to do. Pause the video and apply Newton's laws. Okay, so if you've applied Newton's laws, then you've summed the forces. There are only forces acting in the vertical direction, either up or down. So you've summed the forces, F1 and F2 acting up, minus mg acting down, and that's equal to ma. But since I'm just standing here, the acceleration is 0, so that's all got to be equal to 0. Assuming I'm standing with evenly on the floor, with both feet on the ground, I'm not leaning more on one or the other, then we can assume that the two forces acting on my feet are roughly the same. And so when we work it all out, each force, F1 and F2, I'm now just replacing with 2 times F. So F1 plus F2 equals 2 times F. And each of those is just half my weight. Okay. So if you haven't worked that through for yourself, take a minute and work that through. All right, this ends the first video.